Please like, share and subscribe the channel to show your support.
Today we are going to discuss about the circle generation algorithm. In mathematics we are having two basic algorithms by which we can draw the circle. The first algorithm is, or first method in mathematics is called as with the help of Cartesian coordinate method. The second method is called as polar coordinate method. The first method, Cartesian coordinate, or you can say that with the help of x and y coordinate, we are having the first equation x square plus y square equal to r square. This is the equation in the case when you are having the center of the circle at the origin, that is 0 0, and the radius of the circle is given to us r. The second equation, when the circle of center is not given to the origin, it is given to some other place, then in this case the circle of the center is xc comma yc and the radius of the circle is given to us r. Then in this case we are having the equation x minus xc whole square plus y minus yc whole square equal to r square. To plot the circle, if we are incrementing in the x direction, that is in unit interval we are incrementing in the x direction, we can generate the coordinate for the y equal to yc plus minus under root r square minus x minus xc whole square. So this is the method by which we can plot the point x comma y on the circle peripheral. The next method, which is called as polar coordinate method, we will discuss the drawbacks of the both algorithm, why we cannot use these two algorithms directly on the computer graphics for the plotting the circle. The second method is called as based upon the polar coordinate, in which we are having the center coordinate at xc yc and we are having angular rotation theta and the radius is given to us r. Then the point on the peripheral of the circle we can generate with the help of x equal to xc plus r cos theta and y equal to yc plus r sin theta. And in this case we are having the variation on the theta, that is we will increment the theta value, that is first time 1 degree, 2 degree, 3 degree, and in this case we are generating the values for x and y, that is maximum at max we can generate 360 degree, or we can generate, depending upon our requirement, we can generate the different values for the x and y coordinate. Now we are going to discuss about the drawbacks, why we are not going to use these two algorithms directly on the computer graphics or when we are writing the algorithm for the graphics. The first thing is that this method we are not as sure at which point we need to start and at which point we need to stop, because these are the mathematical points, it will generate the mathematical point. The main problem is that at what point we need to start. The starting point is not decided at this circle. The second thing is that if you will see, this is the equation and the point on the circles are unlimited. So in this case the computation is more. For each calculation we have to do this kind of the complex computation each and every time. So these are the 2-3 points which we are having the drawbacks on the Cartesian coordinate method, that is directly we cannot use this method to the computer graphics. The second method, for the polar coordinate method, in this coordinate system, if your circle size is small, if your circle size is supposed is small and you are having for the same variation of the theta, that is for the theta we are having some periodic interval and we have calculated this circle. But suppose that if you will increase, we have generated the points with the help of this theta on the peripheral of the circle or boundary of the circle. If you will increase the size of the circle, or if you are increasing the radius of the circle, so in this case for the same theta value you will have the pixel on the peripheral in the scattered format and your circle will be displayed on the screen not fine. So these are the two methods in the mathematics by which we can draw the circle, but practically we cannot implement these two methods directly on the computer graphics. So for this purpose we are having another algorithm which is called as Bresenham circle generation algorithm, or it is also called as midpoint circle generation algorithm. We will discuss. So this is the algorithm which is given by the Bresenham for the plotting the circle on the display devices, and Bresenham has modified something on the previous algorithm, that is the mathematical algorithm. He has modified to implement this on the display devices practically. So the first modification what he did, that is shift the center coordinate to the origin. That is first what he did, from the center coordinate he shifted the circle to the origin, that is the origin at 0, 0, that is first shifted, and then he plotted the points for the circle peripheral. And the second step, thus Bresenham has identified the symmetry of the circle. This is very important because what we have to do, first we will calculate the pixel for only one symmetry. We will calculate this pixel for the one symmetry, and then we will replicate this pixel to the other symmetry. That is for the we have to calculate the pixel only for the first symmetry, that is for the first quadrant, that is x comma y values. After that we can replicate this pixel with the symmetry given by the Bresenham. This symmetry is generated by the Bresenham. We are not going inside the proof of the symmetry, how he has calculated and displayed the point. We are directly using the symmetry, that is first quadrant it is using xy, second quadrant it is using yx, y comma minus x, for the fourth x comma minus y. In this way he has calculated the 8 symmetry. So what is the advantage of this one? That is, no need to go for the further calculation, just calculate the pixel only for the one symmetry and replicate these pixel values with the help of symmetric values for the different quadrants. The third thing, because Bresenham has given one decision function, that is the decision parameter, how we can select the pixel on the circle boundary. This is inside the circle or which pixel we should grow. It is given by the decision function. Bresenham has contributed the third thing, which is called as decision function. With the help of this decision function, this is fc x comma y. It is generated in the format of x square plus y square minus r square. That is the equation of the circle. Based upon this one, if the function value is 0, that is the circle is the point what you have generated, it is on the circle boundary. The second thing, if it is less than 0, the point is inside the circle boundary. If it is greater than 0, that is if it is positive, if it is negative, this is the value, if it is positive, this is the value. So Bresenham, what he has given, that is when we are calculating the pixel, always you will get the integer incremental value, that is we will increment in the x direction and we have to calculate the value for the y. The Bresenham, what is given, increment in the x direction and calculate the value for the y. The next thing is that always we will get from this algorithm integer incremental values, that is we will not get this kind of the values 2.3 or 2.5, this kind of the value we will not get. We will get or integer. So now we will discuss about the pseudo code for the midpoint circle generation algorithm. This Bresenham circle generation algorithm, it is also called as midpoint circle generation algorithm. Based upon this decision parameter, the name is also given midpoint circle generation algorithm. These are the steps for the pseudocode, or you can say that for the algorithm. The first step, what it is saying that input radius r and circle center xc comma yc, and obtain the first point on the circumference of the circle. That is, we have to center the circle. That is, we need to shift the circle from the center to the origin. So your first point will be x0 comma y0, that is 0 comma r. That is the circle boundary. We get the first point on the circle boundary. The second thing, we need to calculate the initial decision parameter. The initial decision parameter is p0 equal to 5/4 minus r, which is approximate, you can say that 1 minus r. At step number 3, we will start for the iteration for the successive pixel. We will start from k equal to 0, and for that iteration, the initial decision parameter will be considered. And in this case, if the pk value is less than 0, or you can say that if it is negative, then in this case the point will be considered for the further point xk plus 1 comma yk, and the decision parameter for the further pixel value pk plus 1, pk plus 2, xk plus 1. These two things we need to remember when pk is negative. That is this one and this one. This is the pixel value and this is the decision parameter value. Otherwise, the next point along the circle is xk plus 1 comma yk minus 1. We are decrementing the yk value because it is on the circle boundary, so it will decrement. And decision parameter will be this one. The next thing, determine symmetry points in the other 7 octants because we need to calculate the pixel for the symmetry point for the complete circle. So we have to replicate these pixels what we have generated for the first quadrant for the 7 times for the remaining 7 octants. The next thing is that move each calculated pixel position xy onto the circular path with the help of circle center. In the next step, what we will do, the calculated pixel which we have calculated based upon the center of the circle on the origin, we will shift these pixel values to the center value with the help of this equation, that is x equal to x plus xc, y equal to y plus yc. And we can repeat this step number 3 to step number 5 until x is greater than or equal to y. We need to stop the algorithm. So this is the first problem related to the midpoint circle generation algorithm. In this one, what it is given to us, rasterize the circle for the first octant. If the center of the circle is at the origin with the radius given to us 10 may be unit, 10 pixel or 10 centimeter, whatever the unit is given to us, we can consider. But here our focus is to draw the circle with the radius 10, and when the center is at the origin and the main thing is given, the circle we need to calculate for the first octant. We have to calculate the pixel values for the first octant. This is the simplest problem for the circle generation algorithm. We are having more complex problem for the circle generation algorithm. We will discuss them in the further session, because it is not possible to cover all the problems within the one session. So what is given to us, we have to calculate only for the first octant, that is for the first octant we need to calculate. The second thing is given, the circle center is at the origin, that is the circle center is already on the origin. This is the circle center. It is already given to us at the origin with the radius 10. So if the radius 10 is given to us, this one is the radius. So what will be the first point at this place, that is on the y-axis of the circle boundary? It will be 0, r. It is obvious to us that is the first point will be 0, r, that is 0, 10 for this case. So let us start for the problem. We will start from the initial decision parameter, that is p0 equal to 1 minus r. Actually this value is p0 equal to 5 upon 4 minus r. We are assuming this one 1 minus r. Next we will go for this further calculation. If the pk value is negative, that is if the sign of the pk is negative, we will consider these two values, that is for the pixel value we will consider this value, and for the decision parameter, for the further decision parameter we will use this value. Otherwise meaning is that if the value is 0 or positive, we will consider these values. So let us start for solving the problem. P0 equal to 1 minus r. R is given to us 10. So this is 1 minus 10 equal to minus 9. This is given to us. This is an initial decision parameter P0 minus 9. And what will be the first point or first pixel on this computer screen? It is 0, r. So you will get the first pixel on the computer screen will be 0, 10. We will start computing next pixel with the help of this pixel only. So we will start for the pixel. We will start from the first. We need to prepare the table. While calculating the pixel values with the help of midpoint circle generation algorithm, we need to prepare this table. What the parametric values of the table you can see from here. This is the index value k, pk, xk plus 1, yk plus 1. This is actually your pixel of this what we are going to calculate. This is only symbolic. Its meaning is that we are going to calculate the further or successive pixel. It may be negative, yk value is negative, may be possible. This is 2xk plus 1, 2yk plus 1 and pk plus 1. These two things are optional. If you want to prepare, you can prepare, otherwise it is not needed. These two values we will use only for the calculation purpose, that is for the pk plus 1 value. So now let us start the rasterizing the pixel for the circle. We will start from 0, 10. This is the first pixel which is given to us. Now we will start from here. K is given to us 0. Pk at this time is minus 9. So in this case, when the pk value is negative, what will be the pixel value? It is saying that xk plus 1, yk. From this equation, you can increase 1, yk. Yk is yk, there is no change in the yk, so this is 1 comma 10. Next, what is 2xk plus 1? This is xk plus 1, so it will be 2. What is 2yk plus 1? This is 10, so it will be 20. We will use these two values only for the computation or calculation purpose. Otherwise, there is no need to display this thing on the your calculation. You can go for the rough work also. So pk plus 1, what is pk plus 1? The pk plus 1, we will use this value, that is pk. Pk is minus 9 to minus 9 at this time. 2xk plus 1 plus 1. 2xk plus 1 is 2 and 1 is 1. So this value will be minus 6 at this time. So for the next step or next iteration, what will be the value of pk? This value will come at this place. So we will have minus 6 at this time. This is again negative. So in this case, what you will do? You will use again this value, that is xk plus 1 comma yk. Xk plus 1 is 2 and yk is again 10. 2 comma 10. Next, the same thing we need to do. This is 4, this is 20. Again, this is negative, so we will use this pk plus 1, that is pk is minus 6 plus 4 plus 1. So this time we will get the value minus 1. So at the next iteration, this will be minus 1. So again, this is negative. The sign is negative, so what will be the value? This will be 3 comma 10 again. The value of 2xk plus 1, this is 6, 2 into 3 6, this is again 20. So this time again this is negative, so we will calculate the value minus 1 plus 6 plus 1. So this time you will get the value 6 or positive. When you are having the value 6, what you need to do? When the value is positive, the pixel value, it is saying that xk plus 1 comma yk minus 1. Xk plus 1 is 4 because we are incrementing in the x direction, unit increment. So this value, there is no change, only we need to take the decision on y value. This is yk minus 1. So this time the value of y will become 9. Next, 2xk plus 1 is 8 and 2yk plus 1 is 18. Now we will consider this pk plus 1. Pk plus 1 is given to us, pk plus 2xk plus 1 minus 2yk plus 1. So we will consider this thing. This is 6, 2xk plus 1 is 8 plus 1 minus 2yk plus 1, this is 18. So when you will calculate, this is minus 3. Next step, this is again minus 3. The symbol is again negative. So in this case, the pixel value for the first octant will be 5 comma 9. There is no change in the y, and the xk plus 1 is 10 and the yk plus 10, yk plus 1 is 18, 2yk plus 1 is 18. Again we need to calculate the pixel decision parameter from this equation. Pk is minus 3 plus 10 plus 1. So this time we will get 8. That is, we are having a positive value for the decision parameter. So in this case, this is 6 comma 8. This time yk value will decremented. That is from this equation yk minus 1 when decision parameter is positive. This time we are having the positive value. So this will be 12 and this will be 16. So again calculate the decision parameter for the successive iteration. This is pk plus 1, this is pk, this is 8 plus 12 plus 1 minus 16. This will be 5 plus 5, 12 at 20 plus 1, 21 minus 16, it will be 5. So next step, it is 5, this is 7. Because this is positive, it will be decremented 7, 7. What will be the next step? If you will see, there is no need for the calculation. You need to stop when you are having the condition x is greater than equal to y. This is the stopping condition for the midpoint circle generation algorithm. When you meet this condition, that is x is greater than equal to y, you need to stop. So we have to stop at this place for the computation. So these are the pixel values for the first octant from this point to this point. We will get all the pixel for the first octant with the radius 10. We will go for the further calculation for, in the next session. We will start for the more complex calculation for the midpoint circle generation algorithm, because in this one we are having the first octant only and the circle center is given to us origin. So this is the computation for this one. Actually, when we are going to calculate the values, we need to calculate one pixel at one time. Next, we need to shift this to the center and also calculate the other octants same time. But for the computation purpose, this is for our computation purpose, we are computing these values in this way.